Okay, so today we're going to cover Chapter 3, Section 4, and we're going to learn how to find zeros of the polynomial. Now, on the test, when I asked you to find the zeros of the polynomial, it was a polynomial that could be factored. These polynomials, initially when they start out, they cannot be factored. So what we're going to need to do is do synthetic division to bring it down a power so that it's something that could be factored, or if we bring it down to quadratic and it can't be factored, then we're just going to use the quadratic formula. So for this one, the first thing is we're going to be using the factor theorem. So what we're trying to do is when the divisor is a factor, we would get a remainder of 0. So let's go ahead and try our first example. Now, the first couple, they're telling us what the factor is. Now, this given polynomial, the f of x equals 6x to the third plus 19x squared plus 2x minus 3. I cannot factor this polynomial. Number one, it's an x cubed, and it's got 4 terms. So the only thing I really could do with a 4-term polynomial is factor by grouping, and I can't. So what I'm going to do is I'm going to do synthetic division with the negative 3, and I'm going to bring it down a power, so then it's now quadratic that I can either factor, complete the square, or quadratic formula. It's up to you how you would get the rest of the zeros. So I'm going to go ahead and do synthetic with the factor they gave me. This is actually a 0. So the factor would have been x plus 3. Because remember, in order to get the 0, we set the factor equal to 0, and that's how we get x equals negative 3. So let me go ahead and put in my coefficients, 19, 2, and negative 3. I'm now going to do synthetic. I bring down the first term. I'm going to multiply. I'm going to add the column. I'm going to multiply. I'm going to add the column, and I'm going to multiply. Now, if you did not get a remainder of 0 here, you did something wrong, because you were told in the problem that negative 3 was a solution here. So if you didn't get a remainder of 0, you did something wrong. Let me go ahead and add back my variables. Remember, this is remainder, constant, x squared. Remember, the whole reason of doing this synthetic is to drop down the power by 1 to get it to something that's either factorable or something we can use the quadratic formula with. Now, at this point, the choice is yours which method you use. Factoring is the fastest. You can either choose the factor by grouping here or guess and test. I know my other class likes me to factor by grouping, so let me go ahead and just do grouping on this one real quick. So I'm going to multiply the beginning and the end. This is going to give me negative 6. So two numbers that multiply to give me negative 6, but who will add to give me the positive 1. And those factors are going to be positive 3 and negative 2. So again, rewrite the first term, put in one of the two factors. The order that you place them does not matter. I'm going to go ahead and make my groups. A yellow group, and then I'll make a white group so it shows up in this blue background. GCF of yellow is going to be 2x, divide. GCF of the white group will be 1. And now put the two GCFs together, and you get 2x plus 1, and then the 3x minus 1. Now, if it asks you to list factors, you would also have to have listed this one up at the top. And these are all the factors of the polynomial. But we're going to look for the zeros. So what we're going to do is take each of the factors, set them equal to 0. So 2x plus 1 equals 0, 3x minus 1 equals 0, and I solve. Subtract, x equals negative 3. Subtract, divide, and notice my original problem started out with x to the third. So that should tell me that I should be getting 3 solutions. So these are my solutions. Remember these 3 numbers here, they're called solutions. They're called zeros. They're also called roots. They can also be called x-intercepts when we write them as ordered pairs. So this could also be listed as ordered pairs, x-intercepts. So if you see this described on an SAT where they ask you to list the solutions or the zeros or the roots, that is going to be these 3 numbers right here. However, for the x-intercepts, you would write them as ordered pairs. So this process is still the same. The only difference is what's going to be coming up is they're not going to give you one of the solutions. You're going to have to figure it out by finding the possible zeros. But let's go ahead and do the next one. Same process. They're giving us one of the zeros or one of the solutions. So again, I'm going to take the x minus 1, which is a factor. I'm going to set it equal to 0, solve, and now I'm doing synthetic with positive 1. So I'm going to set it up, take all the coefficients, put it in the synthetic box. And the reason why I have to do synthetic is because this original polynomial could not have been factored. So I need to bring it down to quadratic so I can either factor it or use quadratic formula. So I'm going to go ahead and bring down my first term. I'm going to multiply. I'm going to add the column. I'm going to multiply. I'm going to add the column. I'm going to multiply. And again, if you did not get a remainder of 0 here, you did something wrong because you were told that 1 was a solution or negative 1 was a factor. Now I can add back my variables. So this will become x squared. This is the x. This is the constant and the remainder. So 2x squared minus x minus 6 equals 0. It's now quadratic. If it can be factored, definitely factor it. It's the faster way. If you don't want to factor by grouping and you want to guess and test, then you got to FOIL it to make sure it works. So I could guess and test here because my factors of 2 and 6 are kind of small. Or you could do the whole grouping. So guessing and testing, my factors of 2 are going to be 2 times 1, so 2x times 1x. And then my factors of 6, they're negative 6, are either going to be 1 and 6 or 2 and 3. And one of them's negative. It's actually going to be positive 2 and positive 3 and negative 2. Now, once you do this guess and test, if you don't do the whole grouping, you need to double check and FOIL this that it does give you that middle term. And it does. Now, if it asks you to list the factors, you also would have to list the original one they gave you. So these are the factors of the polynomial. And now to get the solutions or the zeros, set each of the factors equal to 0. So here, add 1, x equals 1, subtract 3, 2x equals negative 3, divide by 2, x equals negative 3 over 2, add 2, and x equals positive 2. So again, these are my roots, my solutions, my zeros. They can also be x-intercepts if you write them as ordered pairs. Next one, we're going to do exactly the same thing. They're telling us one of the zeros. Now, if you were going to graph this, you could graph these 3 x-intercepts, add in your end behavior. So it's an x cubed. So my end behavior would be like this. And then you could also plug in a 0 to get the y-intercept and then graph it. So again, finding the zeros gives you a bunch of the ordered pairs. Next one, they're giving me one of the zeros. So again, I'm going to do synthetic using that 0, put all the coefficients in here. Gonna bring down, gonna multiply, gonna add the column, gonna multiply, I'm gonna add the column, and I'm gonna multiply. Again, if you did not get a 0 here, you did something wrong because you were told that -5 was a 0. So now let me add the variables back. It's now quadratic. I can either factor it or do quadratic formula. This one, again, can be factored. So again, don't forget about the original factor they gave you. That would be x plus 5. And now this polynomial, the 6x squared minus 13x minus 2, I'm going to factor it. I'm going to factor it into factors of 6. I'm going to use 6 and 1 this time. And the factors of 2 are 1 and 2. And one has to be positive, one has to be negative. Let's go ahead and, actually this should be a positive 2 here. And to get the negative 13 in the middle, they're both negative. And then if you're going to guess and test like this, quickly do the outer and the inner and make sure you do get negative 13 in the middle, which I did. So my guessing and testing worked. So now I can go ahead and set, these are the factors, but to find the zeros, you set the factors equal to 0. 6x minus 1 equals 0, x minus 2 equals 0. So subtract, add the 1, divide. Next one is 1/6. And then here add 2. X equals positive 2. So these are the zeros. So when you're finding the possible zeros, what you're going to do is first put your polynomial in order of decreasing degree, and then to find the possible roots, the list of them, you're going to take the factors of the last term and put it over the factors of the first term. To find all the roots, you're going to have to test the possibles until you find the zeros, where when you do synthetic, you're going to get a remainder of 0. You're going to continue until the quotient can be factored or using the quadratic formula. So let's go ahead and take a look at what I'm talking about. So for the possible zeros on this one, we're going to take the last term, so last over first. So my last term is the 15, and the first term is the 8. So I need to list all the factors of 15 and all the factors of 8. So I could do plus and minus 1 times 15, plus and minus 3 times 5. And these are my factors of 15. Then my factors of 8 will be 1 times 8 and 2 times 4. So plus and minus 2, 4, and 8. Now, to get the list of possible zeros, and when you're doing this on WebAssign, what you need to do is enter them individually. It's not going to let you enter them in as plus minus. So what you're going to do is you're going to take the first term here, and you have to add each one of the denominators to that numerator. So my first zero, possible zero, 1 over 1 is just 1. Then 1 over 2 is plus and minus 1/2. Then 1 over 4, plus and minus 1/4. Then the 1/8. Now I have to take the 3 and do exactly the same thing. So I'm going to take this plus and minus 3, give it a denominator of 1, 2, 4, 8. So now I'm going to add to my list. So plus and minus 3, plus and minus 3 over 2, plus and minus 3 over 4, and then plus and minus 3 over 8. Now I got to do the same thing with the 5. This 3 over 8 didn't show up very good. So now let's do the same thing with the 5. And I'm going to take the 5 and give it a denominator of 1, then a denominator of 2, then a 4, and then of 8. And now I do the same thing with the 15. I'm going to go ahead and 15 over 1 is 15, 15 over 2, 15 over 4, and then 15 over 8. In this list, there are 32 possible zeros. Notice my polynomial is raised to the third power. It's 8x to the third. Out of this list of 32 possible zeros, potentially only 3 are going to work. So if you're not using a graphing utility, and let's say you're a really bad guesser, you could be sitting there doing 29 synthetic division problems until you find the ones that work. But once you find one, notice it's x to the third. It'll bring it down to quadratic. So really all you have to do is find one out of that list of 32. Now, if this were a test question, and we tested on this last year, this would have been a calculator question. And you would have keyed this in to your graphing utility. You would have found one of the possible zeros and then done synthetic division with that zero. Now I'm going to tell you what one of the zeros are, and I'm just going to do synthetic with it. So out of this list, there is a zero located at -5. So I'm going to do synthetic division with -5, and then that's going to bring it down to quadratic. So 80, 50, 47, -15. The only difference of what we're doing now than what we did in the first 3 examples is I gave you the zero, okay? You're going to have to either guess and test or key this into a graphing utility. So I'm going to go ahead and do my synthetic. Bring down the first term, multiply, add the column, multiply, add the column, multiply. Notice I got a remainder of 0. If I were guessing and testing, then that's what I would be looking for. If I did not get a remainder of 0, then I'd start all over again and pick another number from my list. So now that I've got this down to a quadratic equation, now I don't need to guess and test anymore. Now I can either factor it or use quadratic formula. And this is factorable. So I could actually factor this into 4x minus 1 and 2x plus 3. Now again, don't forget about this factor. So if it asks you to list the 3 factors, that's what it would be. And then to find the zeros, you set each one equal to 0. And then solve. So the first 0 was the -5. That's the one I used. Divide by 4. X equals -1/4. Over here, subtract 3. 2x equals -3. Divide by 2. And x equals -3/2. So, and there are your 3 zeros. Again, remember the power in the original polynomial, that largest exponent tells you how many zeros you're looking for. You have a sign. When you go to key in this list of possible zeros here, you have to type it in as -1, comma 1, comma, -1/2, comma, +1/2. You have to key them all in individually, no plus minus. Just read how they want you to separate them. I'm pretty sure it's with commas. So we have last over first. So my last term is +2. So plus and minus 1. plus and minus 2. And then my first term is 6. So 1 times 6 and 2 times 3. And now I need to make all these different combinations to get all my possible zeros. So the possible zero list are going to be plus and minus 1, plus and minus 1/2. And then now I have also plus and minus 1/3 and plus and minus 1/6. Now I'm going to do exactly the same thing with the 2. So plus and minus 2. 2 over 2 is 1. I've already listed it. And then I can list plus and minus 2/3. And then when I do the 2 over the 6, it just simplifies to 1/3. So these are all of my possible zeros. Again, remember when you're entering them into WebAssign, you need to enter them as individual. You can't put the plus minus. In this question, notice it's in x to the 4th. So in order to get it to be something that can be factorable, if after I do synthetic the first time, if it turns into the 4-term polynomial, if it can't be factored by grouping, then I'm going to need to do synthetic division again with a different 0 and then bring it down to quadratic. So let's go ahead and try it. Now, I went ahead and I keyed it into my graphing utility, and I found that 1 is a 0 from this list of possible zeros. That actually works. So let me go ahead and key in type in my coefficients. So 6, 7, negative 12, negative 3, and then positive 2. Bring down, multiply, add the column, multiply, add the column, multiply, add the column, multiply. Notice if you were guessing and testing without a graphing utility, then if this was not a remainder of 0, then 1 would not have been a solution here. Now, if I go ahead and add back in my variables, let's take a look to see if this is something that can be factored. And notice if I go ahead and take a look at this, so notice this is not something that I can factor by grouping. So what I'm going to need to do now is take this new bottom row, and I need to do synthetic again. And again, I would have keyed it in my graphing utility and saw all of the zeros. And out of my possible zero list, negative 2 is a 0 that I'm looking for. So now I'm going to do synthetic with negative 2, but using this blue row here. So 6, 13, 1, and negative 2. Bring down, multiply, add the column, multiply, and again, I've got a remainder of 0. So remainder constant x squared. So 6x squared plus x minus 1 equals 0. Now it's quadratic. I can either see if this can now be factored. If it can't, then I'll use quadratic formula. However, this is a factorable trinomial. It will factor into 3x minus 1 and 2x plus 1. Now, if it would have asked me to list all of the factors, I would have needed to go back and grab these numbers that I just did synthetic with and turn them into factors. So I could put the x minus 1 here, opposite sign, and then the x plus 2. These are all the factors of that polynomial. But to find the zeros, remember you take each one of the factors, set it equal to 0, and then you're going to solve for x. So I'll set each one equal to 0. The first one gives me that positive 1 that I used for the first synthetic division problem. This one gives me the negative 2 that I used for the other one. Now, if you're not keying this into a graphing utility, then you would guess and test and do synthetic until you get the remainder of 0. But if you can use a graphing utility, you'll key it into your graphing utility, And then what you'll do is once you find one rational zero, do synthetic with that rational zero to bring it down a power. And if it's an x to the fourth, you may have to do it twice to get it to quadratic. So these are now my 4 rational zeros. Now, the next examples have irrational zeros. So for number 6, again, let's list our possible zeros. Now, this potentially could have been a test question without a calculator, because watch how many possible zeros we're going to get here. So the possible zeros are going to be taking last over first. Last over first. So the last term is 5. So plus and minus 1 times plus and minus 5. And then the first term is just 1. So my list of possible zeros are just 1 over 1 and 5 over 1. So plus and minus 1, plus and minus 5. There's only 4. And I'm looking for 3 zeros. However, not always are all 3 zeros going to be -1, +1, -5, or 5. It could be a radical zero or even an imaginary zero. So we need to find at least one rational zero from this list. And what we would do is guess and test till we find it. And the one rational zero that works here is going to be 1. So this would be a question where I would expect you to guess and test. So remember, this one's missing the x term, so I got to hold the spot in my synthetic with a 0. So I'm going to put in 1, 4, 0, and -5. I'm going to bring down, I'm going to multiply, going to add the column, multiply, add the column, multiply. I found it. This has got a remainder of 0. I can now add back my variables, x squared, x, constant, remainder. So x squared plus 5x plus 5 equals 0. So I found one 0. It's x equals 0. Now, notice this one. There are no factors of 5 that will add and give me 5. So I can't factor it. I got to do quadratic formula. So if it asks you to list the factors, it would be x minus 1 times x squared plus 5x plus 5 equals 0. These are the factors. The zeros, I already knew this one is going to be x equals 1. This one, I have to do quadratic formula. My a is 1, my b is 5, my c is 5. So I'm going to do opposite of b, plus or minus b squared minus 4ac, all divided by 2 times a, -5 plus or minus 25 minus 20 over 2, -5 plus or minus 5, the square root of 5 over 2. My remaining 2 zeros are irrational. They're radicals. Let me show you what this looks like when we key it in the calculator. Here are going to be x equals 1, x equals -5 minus radical 5 over 2, and x equals -5 plus the square root of 5 over 2. I'm okay with you leaving it as the plus minus, but know that 2 of your answers, your zeros, are irrational. So this is how you would have to show the work for these when it's irrational. The same thing is going to happen when they're imaginary, and that's what's going to happen on number 7. So for number 7, I'm going to go ahead and list my possible zeros. So for the possible zeros on 7, I'm going to take my last over first. My last term is 3. So plus and minus 1, plus and minus 3. My first term is just 1. So my possible zeros are just plus and minus 1, plus and minus 3. Because when you want 1 over 1, it's 1. And then 3 over 1, and it's just 3. So now I need to do synthetic with one of these four numbers. Again, I'm going to do 1. 1 is a lot of times what happens, but not always. So I'm going to go ahead and do synthetic with 1. This one is missing the x squared, so I got to hold the spot, do synthetic. Now, if I choose a 0 that I think is one of the answers, again, I'm either going to do -1, +1, -3, or 3. I've got 4 choices. If I don't get a remainder of 0, then I scrap that and start over again. So I'm going to bring down, I'm going to multiply, I'm going to add the column, I'm going to multiply, add the column, multiply. I got my remainder of 0. I'm now going to add back in my variables, and now I can use quadratic formula. X squared plus x plus 3. So this is a factor, and then also the one from the beginning. These are the factors. This gives me x equals 1. This one, there are no factors of 3 that will give me 1. So again, quadratic formula. A is 1, B is 1, C is 3. Opposite of B, plus or minus b squared minus 4ac, all under the radical, divided by 2 times a. Simplify what's under the radical. I get 1 minus 12. Simplify that. I get -11 under the radical. So my zeros are going to be -1 plus or minus I radical 11 over 2. So my 3 zeros are x equals 1, x equals -1 minus I radical 11, and you would list these as a 0 even though they're imaginary. When you key this into your graphing utility, you're only going to see it hit the x-axis one time because you're not going to see the imaginary x-intercepts. So once you keyed it into your graphing utility, you're going to see it hits it at 1, and then you have to do synthetic with 1 to bring it down a power to do quadratic formula to get the imaginary 0. So if I key it in Desmos, 1 real and 2 imaginary zeros, the graph itself will look like it's only touching the x-axis one time. And now for my last one, I'm going to go ahead and list the possible zeros. So again, we do last over first. My last is plus and minus 1, 2, 4, and 8. All the ways to multiply to get that last term, which was an 8. And then the first one is just a 1. So my possible zeros are going to be plus and minus 1, 2, 4, and 8. So again, if you're not using a graphing utility, you're going to guess and test until you find the one that works. If you're using a graphing utility, go ahead and key it in your graphing utility, find one rational 0, and do the synthetic with that rational 0. I'm going to go ahead and do synthetic with 1. Now remember, you need to make sure that you account for every single term. This one is missing an x to the 4th, so I'm going to hold the place with the 0. Then 1, 2, -12, positive 8. Bring down, multiply, add the column, multiply, add the column, multiply, add the column, multiply, add the column, multiply, add the column. So if you were guessing and testing, and if this number was not a 0, then you would have to start over again and pick another number from your list of possible zeros and then do synthetic with that one as well. So now let me go ahead and add back in my variables. X squared, x to the 3rd, x to the 4th. Remember, my original problem was an x to the 5th. So once you do one synthetic, it just drops it down 1 power. So now x to the 4th, plus x cubed plus 2x squared plus 4x minus 8. I cannot factor this, so again, I got to do synthetic again. But remember, you're doing synthetic with this newly formed bottom row without the 0. So another 0 out of the possible 0 list could be -2. And then put in that row, 1, 1, 2, 4, and -8. Bring down, multiply, add the column, multiply, add the column, multiply, add the column, multiply. Add back in the variables. So I have x to the third minus 1x squared plus 4x minus 4 equals 0. Now, at this point, go ahead and check to see, can this 4-term polynomial be factored? Yes, it can. I can factor by grouping. If it couldn't, then you'd have to do synthetic again to drop it down to quadratic. My GCF of the red group is x squared. My GCF of the blue group is going to be +4. And now I take these two, put them together, x squared plus 4, and then the x minus 1. And now remember, you also have the factors from the beginning, the two that you did the synthetic with, and then this one becomes an x minus 1. These are the factors, and again, set each factor equal to 0. And then solve for x on each one. Remember, we were looking for 5 zeros because it started out with an x to the 5th. So we will add 1. The first 0 is 1. Subtract 2. Subtract 4. X squared equals -4. When I square root this, I get plus and minus 2i. I'm still going to list that as a 0. It's just not going to be an x-intercept. So my 5 zeros are 1, -2, positive and -2i, and then +1. Notice the +1 occurs twice. This would be a multiplicity. So at x equals 1, it's got a multiplicity of 2. So remember, this is going to be like a bounce or a touch and turn away from the x-axis. So it'll be a touch and turn. The other 3, this one we would not graph because we won't see it, but this one would cross the x-axis because it occurs once. So it has a multiplicity of 1. And then same thing for the positive and -2i. So again, this one, once we did the synthetic twice, we were actually able to factor it once it got to an x cubed. But if we weren't able to, we would have dropped it down one more time, and then we would have got it to a quadratic that we could have factored.